Okay, today we're going to look at the start of logs and exponentials. First of all, I want to remind you what an exponential is. Remember, if we have a function which is a to the power x, so the variable is the power and the base is the constant, then that's an exponential. Okay? For example, 4 to the power x is an exponential. The x is the variable and it's the power. If you remember back when we had a brief look at these earlier, the inverse of an exponential, okay, the inverse function is log. Okay, so it'd be log to the base a of x. Okay, so if we've got 4 to the power x, then the inverse of that would be log to the base 4 of x. I don't know if you remember from functions, but the graphical connection between a function and its inverse, remember, is a reflection in the line y equals x. Yeah, if you remember, if we reflect in y equals x, which effectively means the x and the y coordinates swap over. Yeah? Okay, when we're doing it. So basically, if we want to plot the inverse, we would swap the x and the y coordinates over, because that's what a reflection in y equals x does. So I've told you that because we're going to have a look first of all at the graphs of this and then some easy conversions using logs and exponentials. Okay, but first things first, we're going to have a look at the graphs. Now, remember, it's the power. So if I said x is minus 1, if we're dealing with 4 to the power x, 4 to the minus 1, remember, is the same as 1 over 4, which is a quarter. So that would be a quarter. If I put 0 in here, remember, anything to the power 0 is just 1. Okay? And if we put 1 in there, we're going to get 4 to the power 1, which is 4. 2 in there would be 4 squared, which is 16. Yeah? You can see these things grow very rapidly indeed. So if I was going to plot that, we've got minus 1 a quarter, which is way down near the axis, but not on it. We would have 0, 1, which is about there. Okay? 1, 4, which is about there. And 2, 16, which is about there. You can see how quickly this thing grows. Yeah, gets steeper and steeper and steeper. Okay, remember, so that's gone through 1, 4, 2, 4 squared, which we could write as 2, 16. Yeah? They always go through 1, and that was minus 1 a quarter, because it's 4 to the power minus 1. So that is what the graph of y equals 4 to the power x would look like. Now, any exponential graph will always go through 1 on the y-axis. And, you know, if we're doing a general case of this, if I just do a little sketch down here, okay, if we had that, if the general case of this thing, they always go through 1, yeah, and it would go through 1, a to the power 1, 2a squared, 3a cubed, and so on, yeah? Minus 1 would be a to the power minus 1, which is the same as minus 1, 1 over a. So that's the general sort of picture that the graph of, that would be y equals a to the power x. That's the general graph that you would get for an exponential function. Okay? Now, remember what we said for a log graph. All we're going to do is swap the x and the y coordinates over. So that means I'm going to swap these two over. So I've got a quarter minus 1, 1, 0, okay, 4 1, and we're going to have 16, 2. Yeah? So if I was drawing that on here, now, quarter minus 1. So minus 1, a quarter, it's very close to that axis. Remember, what we're doing is reflecting in y equals x. Okay? It goes through, instead of going through 1 on the y-axis, it will always go through 1 on the x-axis. And then you see it's gone through 4, 1 instead of 1, 4. So 4, 1 would be there. Then we're going through 16, 2. 16's there, 16, 2's about there. So it would look something like that. Yeah, it's gone through 4, 1. Remember, it always goes through 0, so goes through 1, 0. And that would have been a quarter minus 1. And the last point over here was 16, 2, because it's 4 squared. Okay, so that's what the log graph would look like. That would be y equals log to the base 4 of x. Okay, always goes through 1. So I'm going to draw this on the same thing here. So we know instead of it would go through a to the minus 1, 1, 1 there, a 1, a squared 2, and so on, a cubed 3. So it would look like that. The blue one would be log to the base a of x, okay? And it is a reflection, as I said, in y equals x. Okay, so that's the basic graphs for a to the x or log to the base a of x. So for an exponential, will look like that. However, one thing, if this base bit here was less than 1, I'm not going to do it here, but if it was less than 1, your exponential would look the other way round. Okay? Because, yeah, it would. However, I'm not going to go into details with that, but that is the general shape of an exponential. That's the general shape of a log. Yeah? And remember, to go between the two, all you're doing is swapping the x and the y coordinates over, because that's how we know we graphically find the inverse. The next bit of this video, I'm going to do a few simple cases of how we can use the fact that one's the inverse of the other in order to work out a few very simple logs. Okay, before we go on with this, I'll remind you of a couple of things. Remember, from functions, the inverse of the function takes you back to the original, the x. Similarly, the function of the inverse also takes you back to x. So when we're dealing with logs and exponentials, okay, that means that if I do this one, the top one there would be log to the base a of a to the power x. That's just equal to x. And that is the one we use quite a lot. You'll see in these, that's what we're going to be using here. But similarly, equally well, if we looked at the bottom one, that version of it would be a to the power of log to the base a of x. That also takes you back to x. Okay, so basically log to the base a and a to the power cancel each other out. Okay, just taking you back to what the thing was. Okay, let's look at this first one. What helps with this, if you remember that 4 is 4 to the power 1. So, remember we're using that. Just takes me back to what the power was. And the power here is 1. So that's just equal to 1. This, we've got to write it as a power of 3. Okay? Because it's log to the base 3, we must write it as a power of 3. I tend to use fingers for this because 81, if you're going up, you're multiplying by 3 each time. So 3, 9, 27, 81. So that's 3 to the power 4. Okay? You're multiplying 3 4 times to get to 81. Okay, so now we've got it in that form, we can just write 4 using that again. Look at this one. Now here, first of all, that's 1 over 5 squared, isn't it? But remember, if we do 1 over as an index, that's a negative. So that's 5 to the power negative 2. So again, the power and the log cancel each other out. So that just gives me minus 2. Last one here is a little bit tricky, but you've got to be thinking that if that's bigger than that, you should be thinking about roots, yeah? Now I know the square root of 16. You know that, sorry, let's do it the other way. Let's do it. 2 to the power 4, you know, is 16, because 2, 4, 8, 16. Yes? So, the fourth root of 16, so 2 is equal to the fourth root of 16, which is 16 to the power a quarter, written in index form, isn't it? Yeah? So what I have is I have log to the base 16 of 16 to the power a quarter. Remember, the log and the base cancel each other out. Therefore, what we're left with is a quarter. Okay? You should now be able to have a go at the questions in the first two exercises. Just do the questions I've asked you to do. Have a good day.